go ahead and get started.
All right, here
All
we
right.
go.
Recording in progress.
My name's Anthony Ebert, and I'm doing unveiling patterns in data with histograms, box plots, and scatter plots. So we're going to be doing a little bit of graphing today. Okay, so my targeted grade level for this is 10th grade. Trying to cover three standards: IDA 1, IDA 2, and IDA 3. Represent data plots. Represent data with plots on the real number line, right? Dot plots, histograms, and box plots. IDA 2, use statistics appropriate to the shape of the data distribution to compare center, so median, mean, and spread, interquartile ranges, and standard deviation of two or more different data sets. And IDA 3 is interpret differences in shape, center, and spread in the context of data sets, accounting for possible effects of extreme points or outliers. Skills, goals, and language for this lesson. Okay, students will identify and create histograms, box plots, and scatter plots using real-world data sets, analyzing and interpreting data distribution, trends, and outliers. Some key terms: frequency distribution. Okay, this is the way in which data points are distributed across various values. Interquartile range, a measure of variability based on dividing a data set into quartiles. And quartiles, values that divide a list of number into quarters. I'll get more into what all of that means later. Standard deviation, a measurement of the amount of variation or dispersion in a set of values. An outlier is a data point that differs significantly from the others that have been observed. And a percentile is a measure used in statistics indicating the value below which a given percentage of observations in a group of observation falls. Again, these are a lot of big words, which I will be getting more into in just a sec. Okay, so for the introduction part, right, this lesson is aimed at students who are going from pure number data sets and transitioning them into a visual representation of that. So descriptive statistics provide us with the tools to summarize and describe the essential features of a data set, and today we build on our understanding of measures like mean, median, mode, and range, setting the stage to dive deeper into data analysis. And so the way we're going to be doing that is we're going to be moving beyond strictly just numbers, and we are going to be turning them into graphical representations using histograms, box plots, and scatter plots that are going to allow us to visualize the data, making it easier to spot those patterns, trends, outliers that it's a little harder to see when it's just a bunch of raw numbers thrown at you. Okay. And so to get things kicked off, I want to pose a question to you guys. How does the daily screen time of teenagers compare across different countries? Okay, so we're going to look at the data set for this first, so purely just numbers, and then we are going to see if graphing it out makes it a little bit more easy to understand. And so here is the data sets. On the left, you have the country, and on the right, you have the number of hours per day that they're spending with their devices. So again, this is making an argument for graphing things. As you can see, there is a lot going on. If I asked you to find the lowest amount of screen time in a country, or which country had the lowest amount of screen time and which one had the highest, it'd probably take you quite a while, right? You'd have to go through each of the numbers, identify where you see the highest and where you see the lowest, and working through that would be pretty time consuming. But being able to plug this into a graph, or let's say we take a map of the world and color code everything, it makes things a lot easier, right? The darker it is, the more screen time that country consumes. So you can see places like Brazil, South Africa, and the Philippines are some of the highest consumers. And then some of the lowest consumers are places like Japan and Denmark. Everyone that's gray, like Greenland and these central countries, are ones that were unfortunately not part of the data set. So it's a little hard to distinguish between the whites and the grays. But this is just to show you that looking at this is a whole lot easier to interpret and understand than looking at something like this, right? This is too much information to take in all at once. Whereas if you put something into something that is graphically designed, it's a little easier to understand and break it down. So we're going to be going over how to create our three types of data. We're going to be using the same data set for all three graphs, and I'm going to be breaking down the steps. Okay, so first we're going to start with a histogram. We're going to be doing histogram, box plot, and scatter plot. Okay, so a histogram displays the distribution of data across different intervals, showing us frequency of data points within each interval. Okay. Creating a histogram by hand with a set of 10 numbers involves several steps to organize and display data visually, but here's the straightforward approach that we're going to be taking. First, you need to collect your data. We're going to be using student test scores. Okay. These test scores are out of 100. Okay. 100%, right? So our numbers are going to be 72, 88, 95, 68, 82, 75, 91, 77, 84, and 89. We're going to be taking these and turning them into a histogram. Okay. So in order to properly set up a graph, we need to first determine what our range is. So we need to know what our smallest value is and what our largest value is. So looking at the numbers, there's only 10 of them luckily, so it's pretty easy to break through. You can see that our largest number is 95 and our smallest number is 68, which means that we have a total range of 27, right? The difference between our biggest number and our lowest number is 27%. Moving on, we're going to be choosing suitable intervals. Basically, when you're working with a histogram, you are categorizing things by bins. So you're taking a certain range of percentages. Let's say like bin 1 was 65 to 70%. And so any student that scored within that percent range is going to fall into that bin. So this is going to end up looking a lot like a bar graph, but we're grouping students by similar scores. Okay, so we're going to determine how many bins we want for our histogram. Since we only have about 10 numbers, 4 to 5 bins should be enough. And given the range of 27, we're only going to use 5, right? This isn't going to be a huge histogram. We're going to keep, we're going to go by 5-point intervals, and we're going to have 7 bins, which will make a little bit more sense once we break it down like this. So, right, our bin 1 is going to go from 65 to 70, right? Our lowest score was 68, so we want to make sure that's accounted for. And then we're just going to go up by 5s. So 71 to 75, 76 to 80, 81 to 85, all the way to 100. Even though our highest number is 95, we want to ensure that all data is covered. And so moving on, we need to count how many numbers fall into each of our bins. So in bin 1, we only have one number, right? Only one student scored between 65 and 70, for a score of 68, right? Our bin 2 had 2, bin 3 had 2, bin 4 2, and so on and so forth. Then we just need to set up a horizontal line for the x-axis, vertical line for the y-axis, and then we are going to start labeling, right? We're going to say that the bottom is the this is going to be a distribution of test scores is going to be our title. On the x-axis or the y-axis is going to be the number of students in that bin, and then along the bottom is going to be our bins by percentages of 5. Again, a lot of that is a lot of very dense information, but if you break it down and just put students into their bins, right, it's a lot easier to recognize that the majority of the students scored somewhere between 75 and 90% on the test. Right, so we're taking our 10 numbers and we're breaking them down into something that's a little bit more visually appealing. Right, so each one of these bars or blocks represents one student, and you can see that the majority of them were focused right here in the middle. Okay, so that's a histogram. Okay, next is a box plot. Again, we're using the same data set. However, we need to order them in ascending order, so smallest to biggest first, right? So I broke it down. Same 10 numbers, 68 to 95. I'm going to put them in order this time because their placement on this line is going to matter. Okay. The first thing to do is find the median. Okay. So our middle two numbers, right? So finding the median is just the middle number of the data set. Since we have an even number, there is no direct middle. So we're going to take 82 and 84, add them together, and then divide them by 2, right? We're going to find the mean of these. Median and mean are different. It's hard to keep differentiating in your mind sometimes. Okay, but since they are both lie in the middle, we're going to take both of them, add them together, divide them by 2, and that tells us that our median is 83, which is an important point we're going to need to put on our number line. And then we need to find the quartiles. Luckily, this is an even number, so our quartiles are really easy to find. You just take half your data set and find what number is in the middle. So 1, 2, 3, 4, 5. This is the first half of my data set, and I can see that 75 falls right in the middle. I'll do the same to the second half, right? 1, 2, 3, 4, 5, and I can see that 89 falls directly in the middle. So you're just taking your data set. I've broken it up into quarters, right? This is 1 quarter. Now, if I go to between 82 and 83, I have a half, and if I go to 89, that's my third quarter, and then all the way to the end is my fourth quarter. So breaking them up into interquartiles, you're literally just turning it into 4 sets of data. Right, our lowest number is still 68, the highest number is still 95, and we are going to graph this out on a plot. So we're going to draw a number line that includes the range of our data. We're going to mark the minimum and maximum values. So we need to mark off the 68 and the 95. And we're going to draw in our Q1 and Q3, our interquartile, which were 75 and 89. Draw a line inside the box at the median value, right? And that represents our median. And again, this all sounds very complicated, but when you actually put it on a graph, it's pretty easy to understand. Right, your lowest score was 68. Your highest score was 95. These are called the whiskers because they come off of the plot and they kind of look like cat whiskers. Right, 83 was our median. 75 was our first interquartile, and 89 was our third interquartile. So you can see that the data has been broken up into quarters. Right, this is 1 quarter of the data, 1 quarter of the data, 1 quarter, 1 quarter, and this is a box plot. It's really easy to understand. Again, just like a histogram, where the vast majority of your scores fell, and then you have the min and the max, and these are kind of where your outliers are going to be, is in these whiskers. All right, and finally, our probably easiest, probably my favorite, is scatter plots, right? With scatter plots, the big thing to remember is that you need 2 sets of variables. So we kept our test scores from before, but now I've paired them up with a second variable, which is the number of hours that those students spent studying. Right, so same exact scores, our lowest is 68 and our highest is 95, but now we're pairing it up with a second variable to see if we can find any trends or comparisons between the two. Okay, again, this one's pretty simple. You're just drawing the X and Y axes and you're plotting the points. So you're going to put a point, you're going to go out to 72 along the X axis and then go up 5 on the Y axis. You're just pairing these up together. And I'm running out of time, and it looks a little something like this. So as you plot students' points, right, 68, the student who got a 68 on the test spent 4 hours studying. The student who spent 95 did 9 hours of studying. And doing things like this makes it really easy to find correlations between data sets, right? You can see here that your test score tends to increase with the hours of studying, right? The more time students spent studying, on average, their test scores went up. So histogram or scatter plots make it really easy to compare data sets with one another and see if there's any trends between the two. Right? It takes the visual data and breaks it down into something that's easier to understand. Okay. Next, the students would go through guided practice, which is them putting all that together and making their own scatter plots. Right? I'd have them, they're going to do a correlation of 2 data sets, so hours of outdoor activity per week and hours of sleep per night. Okay? They have to determine what type of graph is best for representing this. How many variables do you want to visualize at once, which is your key giveaway that this should be in the form of a scatter plot. And once the graph is complete, do they notice any trends? So, they'd graph this out, x-axis, y-axis, and they would correlate the numbers with one another, and they should end up with something like this. Okay, so hours of sleep per night, they have hours of outdoor activity, and the trend that they're supposed to notice here is that there really isn't one. Just because things seem like they should be correlated to one another doesn't mean that they always are. So breaking things down into going from data to a graph allows you to identify if there is or isn't a trend. So this was kind of supposed to be a trick question where they're looking for something that doesn't exist. Right? They're trying to see if any correlation here exists between sleep per night and outdoor activity. On average, you're supposed to get between 6 to 8 hours of sleep. It really doesn't matter how much work you're doing through the day. That's typically where people fall. And then just for funsies, afterwards I was showing them some fun correlation versus causation. Here you can see some line graphs that's showing the points scored by the losing team in a Super Bowl and the number of people killed by venomous spiders for that year. And you can see that they go pretty hand in hand. The lines look almost identical to each other, but I, again, would be hard-pressed to make an argument that the losing team's score in the Super Bowl would impact how many people are dying to spider bites. Here's Miss America by age, and the murders by hot objects, or deaths, murders by hot objects. Yeah, so steam, hot vapors, hot objects, right? Again, they seem correlated. They seem like they go hand in hand, but it's important to think about what data you're looking at and what statistics you're using, because again, these have almost nothing to do with either of. They're not related to each other is the point. And then lastly, they would just go through a warm up and reflection where they reflect on what they learned today. What new understanding did you gain about choosing the right type of plot, right? What are the benefits to some of them? What are the drawbacks? How did the process of creating the plots by hand deepen your understanding? And can you think of real life scenarios where statistical tools like this would be particularly useful? Yep, and then that's it. A little on the long side, but it works.